In this tutorial, we'll discuss hinges and environment interactions. Let's get bricking. Hinges provide a way to set up complex mechanics. Let's use this simple piston mechanism as a first example. As with other behaviors, it's important to set up submodels in Bricklink Studio for parts of your model that will be moving as one piece. First, we set up a control value that we'll use to rotate the shaft. Then we select the lift arm, add a hinge joint, and select the pin from the rotating shaft as the connection point. Two sets of axes appear. The one in the lift arm helps you see the local coordinates of the hinged part, and the other is presented inside the connecting part. The axis of the joint is determined in the coordinates of the connecting part, so in this case we keep axis X, the red axis as the rotation axis of the hinge. You can see that the part already follows the rotation of the shaft. Now we can try adding a hinge joint to the connecting pin of the piston. As you can see, the piston is not moved along with the rest. This is because the system doesn't know that the piston submodel can be treated as a moving part. So let's declare the hinge on the piston submodel. This will make it part of the animated hinge system, not treated as a fixed part of the rest of the model. The center of the lift arm is used by default as the connection point, so now the piston seems to follow that center from a distance. Let's fix this by specifying the pivot coordinates and also declare the green y-axis as the rotation axis. Now the piston follows the lift arm, but it doesn't stay in place in the brick hole. We can fix that by adding a fixed axis constraint on the piston. Let's use the brick with a hole as the reference and specify that motion in the red and green, X and Y axes is restricted. As you can see, now the piston doesn't move out of the hole, and this restricts the movement of the second hinge point, so now the system works realistically. Hinges can also be used in various steering mechanisms. In this steering, for example, the pin cross blocks are now rotated directly by the steering input. To animate the steering control, we can use hinges. Select the corresponding submodel and add a hinge joint to connect it to the moving lift arm. Then specify axis Y for rotation. Then specify the other side. As you can see, the yellow axle now strangely moves out of the hole. This is because this steering mechanism relies on a small play between the elements to work, as the rotation radiuses differ. If this was simulated completely strictly, the parts wouldn't be able to move at all. To specify that we want the yellow axle to stay strictly in place and rather make the other end have the wiggle, we can use the preferred pivot option on the selected hinge. Now it looks nice. Hinges can also be used in more complex scenarios like these from 42-116, from 42-133, or this beast from 42-032. There are individual videos uploaded that show how these models are set up. Now let's discuss environment interactions. We've mentioned previously that parts of these machines aren't physically simulated, they are rather animated. When vehicles are moving, they can push around other objects and collide with other cars. Moving parts of the vehicles will also push around other objects, but external forces aren't applied to the internal mechanics. The vehicle is still treated as one rigid piece of plastic. This can sound limiting. If internal forces would be simulated in the game, then machines like, for example, this bucket loader would need to simulate how much force is holding the controlling handles in place to determine how much it can lift. This behavior certainly limits how machines can interact with the external environment, but still makes similar machines more conveniently playable and more stable in simulation. This can, however, still result in awkward behaviors. Let's take this moving platform as an example. As the corresponding rigid body is staying in place, it is just changing its shape, the car would just slip off this platform. To handle such cases, the game lets you specify interacting surfaces. If the platform is specified as an interacting surface, it will properly drag the car along with itself. This also allows other fun objects like this carousel. This setting is also needed when machines need to drag other objects along, especially in case of forklifts, bucket loaders, and dump trucks. To let forklifts and bucket loaders more easily pick things up from the ground, you can use the shovel mode in interacting surfaces. This will let these parts of the model go a bit under the terrain. This, however, has an undesired side effect that these parts of these models might also go into other environment objects that are not movable. You can also configure parts of the models to be independent rigid bodies. Most often, you'll also use a hinge to connect it to the main body of the model. This mechanism is used to make the Ferris wheel buckets hang nicely from the model. It can also be used to create vehicle trailers. These aren't detachable and reattachable yet. This hanging part of this picker is also an independent body. These separate bodies will react to external forces coming from the environment, including gravity. While it's possible to create more complex structures with independent rigid bodies, these models usually don't work in the same stable manner. They can easily break or behave in other strange ways. I hope you liked this tutorial. In the next one, I'll show you the level designer. Stay tuned.